So the build is done, and I just turned on the uranium. It'll take a while for it to ramp up, so no need to see that whole thing. We've got maybe 5 or 10 minutes before the uranium will flow. The 3 drone ports at the bottom of the screen are where the uranium is coming in. Each of those ports has 2 drones, one owned at this end and one owned at the other end. So at some point, the uranium will start arriving at the other port. Some drone is going to get the first bit of uranium. His partner will probably get a partial load of uranium. But after that, we should get into the swing of things with everybody getting whatever it takes to maintain 600 units per minute from the miner all the way out to here. So our belt capacity is 780. So you can see what it looks like when we've got a burst. So this is what it'll look like when we're moving the whole 780 per minute that a belt can hold. But that means we're not going to keep this up. We're going to have gaps between them. The initial gaps are going to be long because we aren't really ramped up. But even when it's ramped up, we'll have gaps in between bursts of uranium because we only are able to get 600 out of that particular mine. Only 600. Yeah, and that's only going to get us 180 gigawatts of energy. So these guys are doing pretty good here. The uranium is pre-split into 5 down here. It's a standard 5-way splitter. We've got in the middle here a 3-way splitter, which splits into 2 more 3-way splitters, so a total of 6-way splits. And one of those ways we take back to the beginning so that it's whatever it's carrying will get evenly split across. So we end up with getting the same amount on each of the 5 belts going out. And we can see there that indeed we are evenly spread out across the 5. We get in here. Let's take this guy, for example. Most of these smart splitters are set to prioritize and turn it into a manifold. So for instance, we're going to stuff this guy full of sulfur before we move on to this guy. But the uranium, we're just doing an even split. So even split by 5 and then even split by 2. So we have each one of these guys is getting 1/10. And we see that we've got 8 there and, whoops, and so on. The uranium output turns into in case uranium cells. And about every 2 minutes, we turn out 3 of them. Yeah, it's a long time. Why is it showing 300 seconds? .300 seconds is the unoverclocked time, I think. Anyway, this turns out 3 at a time. So it's 0.6 per minute, and 0.2. I guess it is 5 minutes 5 minutes per group of 3 base rate, and that'll be 2.5 times as fast. So 2 minutes. And once it has finished a fuel rod, almost there, we can almost start. Yeah, it'll be 2 more minutes. Once it's finished a fuel rod, this was not by design, but the fact that I'm running my fuel rods below the deck puts them in the shade and they glow. So I'll be able to duck under here and just glance through, and any fuel rods in this area will just light up and they'll be obvious. In fact, during debugging, 2 of the belts had breaks in them where they weren't passing the fuel across because there was a gap. And it was easy to see the fuel rods backing up right before the break. So very nice. So I recommend that you route your fuel rods and any other radioactive you want to be able to find quickly, route those underneath everything so you can see them move. Which means that perhaps this entire area, I should build a platform over it to put it all in the shade so we can see our radioactive stuff. I might. I probably won't, but I might. So right now we are just waiting for our first set of fuel rods to be delivered. And all of these should light up. Now, we are receiving enough uranium to run this many reactors at 240%. These are all overclocked to 250%, which means that briefly they're expected to consume their fuel and then briefly go idle before the next fuel arrives, if the fuel is arriving perfectly timed. If all of them go idle at the same time, we could have problems. And if that starts happening, I will downclock them back to 240 so that it matches up. And we'll just deal with the fact that we may end up with a backlog of fuel building up. And actually, you can't copy the overclock from reactor to reactor. So I would have to go in manually and do it. Oh, and there we go. We are starting to burn fuel. So the fuel rods come out in groups of 3. And you can see the little bits of nuclear waste coming out and being processed now. And that should be all over. The other thing that's nice from the bottom is when a nuclear reactor is running, it glows blue all the way through the foundations. So I can go down here and just skim through and see which reactors are running. And I can see that this first set is going. This is looking really good. I think everybody fired up at about the same time, which is good in a way and bad in a way, because if they all shut down at the same time because they have not quite enough fuel left, then we are, well, tell you what, I will watch for that to happen, and if it does, I will start going through and changing everybody to 240%. So if we cut this off the grid, we see that our nuclear reactors here are generating 187.5 gigawatts. So everybody is up and running. The difference here is the coal plants and the oil plant and the other nuclear plant. And the other nuclear plant, you'll see it dip up and down. That's the effect I was talking about, where the reactor would run out of fuel. Oh, look at this. That's not good. So reactors have stopped burning fuel. Is everybody healthy? I see. Okay, we're not backed up. I don't see any nuclear waste that's backing up anywhere. Okay, so what I think I'm going to do is I'm going to start off by downrating these to 200%. Notice it came right back up, because they can hold some fuel internally. So I'm going to run them all at 200% for a while. And then I'm going to bring them up to 240, which should keep level. Say when they get two pieces of, two rods in them that aren't the one they're burning. So how long does this, it's not giving us an estimate on how long it takes to burn a rod. I think that's the trick, is to run them at less than your production rate for the fuel rods until they all have a little bit of a backlog, and then bring it up to match. So we have 30 of these, and they're going to be 5 gigawatts each, which means we're bringing this down to 150 gigawatts rather than 180. I believe that's everybody. Math says we missed somebody. That should be exactly 150, and it's 151, 250. Let's go across the rows and back up. That's an awfully weird number. So, drops down to 145 when somebody isn't ready. There you are. Make sure we got it. Okay, so now here we are at 150 gig. So I wonder what fuel rods stack to. Okay, so I'm going to Google really quick, and I'm going to find out in Satisfactory how many fuel rods does a reactor hold. Okay, that pointed me at the main wiki page for the reactor. which actually doesn't seem to say how many fuel rods you can have in one at a time. Okay, so the saves are taking a fairly long time. And I'm starting to get stuttering now and then. So we got a new fuel rod in here. And we're still burning the old one. That's good. So let's start with this guy. What have we got? Can we get 3 of them? I probably want to watch and make sure we don't get fuel rods backing up out here, but we may not see them because they may be stuck in the lifter hood. Oh, while we're here, we can verify that this is actually working. So this reactor is intended to consume all of the water that's being recycled over here. So this fluid buffer should stay pretty dry. The buffer is only here if the machines provide bursty output, which at any time exceeds what the reactor is willing to take in. And this reactor, this is pulsing often enough that we may never get a burst of water that needs to go into a buffer. So that's what the whole array looks like when all of the reactors are churning away. Little wisp of steam coming out the top. I think I'm going to go ahead and start putting this to 240. Since I have to type it for each one. I wonder if I can copy paste just that. Yes, I can. I still need to insert the doohickey. Actually, it's easier to hit 4 than hit Control V. Why is this idle? Somebody is producing fuel slowly. So these two are being idle. So is he. So it's the second set. Okay, let's continue. Remember which one that was. That group of 3 comes from one manufacturer. We need to find it. Okay, so I've done the first 2 columns. So it's the 3 that are in the back on this column here that suddenly went idle. So that was coming in on this lane, which is coming in on this lane, second lane, this one. It was coming down here. Okay, so let's peel up the ceiling. This machine right here is running slow somehow. 8% it's saying. %6. Quick wire. We are not getting our quick wire. And the quick wire is here, but it's not there, which means that wasn't hooked up. Or that's programmed, that's hooked up. Oh, graphical issue. There's no quick wire here. So my prioritization scheme for distributing quick wire here is not working properly. So I think what I need to do is program these so that the priority goes left and the overflow goes straight. That's interesting. Yeah, the graphics fooled me because it showed no quick wire on this belt. It still shows no quick wire. There we go. So this first belt should prioritize going out the right, which should take most of it. Belt above it should prioritize diving down and merging in, which should provide enough quick wire to get us going here. And in combination with that, the remainder from the first belt should continue. So coming out here, we should have some fraction of a belt. So the problem is that this isn't managing to fill the early guys fast enough. I wonder if we actually have quick wire production problems. It looks like one of the belts is just backing up, which means that's going to cut our production. It should only back up if we're producing more than we're actually consuming. And it is correct that only one belt should back up in that case. Let's see if it's still a problem. I did adjust the mergers. It's tempting to take the overflow from this, so any that come out here, and just merge it back in over there. But how are we sitting here? We are not providing anywhere near enough here. Oh, that's filling up. Okay. As long as these guys are filling up, we're good. So yeah, it's weird. I guess once it fills up, we're getting manifold behavior again. Good, good. Yeah, the trick was that I wasn't bringing enough down early. So let's continue onward. So we've done the first two columns. And he gets to 240. I wonder if the quick wire was responsible for those big dips in output. Yeah, anyway, having our consumption balance out what our production is supposed to be means that we probably won't get any big gaps in our output from the reactor. And we probably won't build up excess fuel rods. Okay, so our production is 2 gigawatts short, which means 2 machines I didn't get properly set to 6 gig. So we're going to go backwards through them, and I'm checking the target megawatts for 6,000. Okay, there's that one. Looks like it was the 2 that I had noticed there was a problem with. I didn't actually finish up. Whoops, not 20. Okay, so we are up to 180 gigawatts. And some of our machines don't have excess fuel in them, but that's all right. So if I really was worried about it, for those 3 machines, I could open up their particular manufacturer here and crank this guy up to 250 and crank that guy up to 250, and that would give us a little bit of extra production, get the fuel rods out a little sooner. But for the moment, I am just going to let that ride. And what I'm noticing is that this guy is not keeping up with his homework. Why would that be? This claims he's running, well, the percentages are going to be off because I keep running it up and down. So these guys want if this is running at 240, which is anomaly correct, then it'd be 90 here and 30 the other one. So 3/4 of our waste should be going into here. Instead, we're backing up. Almost like too much of it is going that way. So we're splitting. Bingo. That belt was missing. Which means that this machine was getting half of the input. So I am not sure if this is going to cause this guy to start to run down. I think we may end up with just this much backlog permanently on him. Unless we can route it over that machine, or I can take that guy out and watch very carefully. That should work. Once all of him, once this guy looks like these guys over here, I can put that one belt back in. Lots of small errors in this build like that. Mainly because I couldn't use blueprints effectively for these large builds. I mean, I could have put a blueprint together for a section of this, the belt work here, for instance. But it's almost easier just to drop down the two splitters and a merger and hook them up manually. So he's got 500 uranium waste on board, and he's running less. So let's actually starve out this path a little bit longer. Interesting that they do some variable power here as it spins up and ramps back down. That should do it. I finally got impatient, just moved him manually. Thank goodness for God mode, huh? Okay, so we still have more uranium waste sitting in this machine. We've probably got more uranium waste in here as well because we backlogged. But now it's moving. Does anybody else look odd? Well, these look good. So this jagged line, which is from our fuel rods being recycled, used to spike up and spike up and spike up from the other reactor. Now we've got basically triple coming through, which means each one of those plutonium fuel rods is a big chunk of coupon points. But we've gotten so many coupons now. Look at how many points we have to go before our next coupon. So the reactor's been set to 240% OC on all 30 units. We have verified that our waste processing is working. Our consumption, you see our production is at 180 gigawatts and it is rock solid. I am going to put that back on my main network. And we now have over 300 gigawatts of power to run our factory. And now I have to decide if I'm going to make that final delivery. And if I'm going to do it, how am I going to accomplish it? Well, I'm going to work on one at a time, or will I try to do a grand build? Will I be deleting all of the units of the base that I set up over here in the west? There's a whole bunch of one-off little factories over here that build various things. Do I want to get rid of them? If I turn on, let's see, resources. Do I want to plan a grand factory that grabs the resources and tries to finish off the phase 4 stuff at some reasonable rate, or do I want to build something that just plods along and maybe I just leave it running for 24 hours to get it done? At this point, doing this factory really scratched my itch for building something big and complicated, which required me to learn new techniques and make effective use of blueprints and bring together everything I knew about how to set lifts up appropriately and the old vertically oriented belt systems. I'm still not happy with prioritizing this 4 belts into 5, so there's still some things I could learn. This factory has over 500 hours in it. This factory alone has 500 hours in it. My satisfactory playtime is 1,300. This is over a third of the time I spent playing Satisfactory at all has been this factory in experimental for Update 8. That's a severe ramp up with Update 8 in my game time in Satisfactory. I'm happy with this. They have done a lot of good things with fixing blueprints and I think especially the being able to start building something and hit H to turn it into a hologram and be able to nudge the hologram a meter this way and that. That's the really, really big thing. Upgrading to Unreal Engine and having it look prettier, that's great. I don't necessarily go after games based on how pretty they look. I'm not a high definition, high precision graphics person. I mean, I enjoy it and I appreciate it, but if you give me a game with fantastic graphics and bad gameplay, and then you give me a game with fantastic gameplay and bad graphics, I'll be playing the one with good gameplay. So you can probably guess how much time I've spent playing Dwarf Fortress. Way too much. And then a game like Satisfactory comes along that has both good gameplay and good graphics. I'm looking forward to the real release when they have, they're talking about having some sort of storyline. I'm interested in seeing what they do with that. We live in a great time right now. We've got Satisfactory. Baldur's Gate 3 just came out, which is another game with fantastic gameplay and good graphics. We've got Starfield coming up, which I hope will crest that bar. See if Bethesda Game Studios can pull it out and do all the things I know they can do well without doing all the things that I have seen them do badly. So yeah, maybe if they can have fewer bugs in Starfield than they've had in some of their other releases, that'd be great. Otherwise, I will be yet another person waiting for modders to fix their bugs. But that is a nuclear reactor facility. And yes, it could be smaller, but not a lot. I think that's it for this recording, and I will be back when I figure out what else I want to do in this save, how I'm going to attack Phase 4, for example. See you then.